All right, good evening, guys. Today we want to look at worded problem that give rise to simultaneous equation. All right, now sometimes you will see occasionally a worded problem, and oftentimes it will lead to simultaneous equations. So sometimes you have to look out for these questions. Occasionally you will see one. All right, so the key thing, once you have a worded problem and you can identify from the question two unknowns that you don't have any actual values to, then you need to write those unknown in some letters, either X or Y. And then based on what you're getting from the question, you should be able to read the question and formulate two equations. And then once you formulate the two equations, then the method is pretty just like what you have been doing when you have been solving simultaneous equation. You're going to choose to eliminate one of the unknown and solve for the one that remains. And once you have solved for that one that remains, then when you get that value, you substitute that value into one of the equations to solve for the unknown that you have eliminated in the first place. All right, so that's basically the whole process. So I'm going to walk you through this question so as to show you how you can formulate your equations. All right, so this example is saying a bill for $74 was paid with $5 notes and $1 notes. A total of 50 notes were being used. Find how many $5 notes were used. Now, the key thing here is that sometimes you are not required to solve for the two unknowns. Maybe it's just one unknown that you're asked to find. And in that case, you have to be careful that you don't waste time and find the other unknown when it is not required. All right, now, based on this question, is there any unknown that you can come up with from the question that you think you don't know and you would want to represent it with either X or Y?
Yes, sir. That would be the amount of $5 notes that were used.
Right. So we don't know the amount of $5 notes. What else can we consider that would be an unknown? Would we know the amount of $1 notes?
No, sir. So that too would have been considered as well.
Right. So because we don't know how many $5 notes and we don't know how many $1 notes. So this is where now we would like to use some letter to represent the amount of $5 notes and another letter, the amount of $1 notes. So we are assuming that the amount of $5 notes is different from the amount of $1 notes. So we have to use two different letters or variables to represent them. So in this case, if we say let the amount of $5 notes be X and let the amount of $1 notes be Y, how could we form two equations to represent what the statement is saying? A bill was paid for $74, right? You use some amount of $5 notes, you use some amount of $1 notes. Now there's a total of 50 notes. Does that give you any kind of clue as to what you can do?
Sir, would you divide?
No, you're not going to divide. You want to think simultaneous equation. So you're really finding two equations.
Sir, would it be like 5x plus? No, sir.
You were onto something just now. This way, so Miss Green, anything that you can add? All right.
Like 5x plus y equal to 74 would be 1, sir.
Well, yeah, well, clearly, if you think in terms of $5 notes,
And
some amount of $5 notes and some
amount of $1 notes here, sir. Would give you this.
together, you should get $74, yes. So before you write the equations though, you need to define X and Y. So you're going to say, let X be the amount of $5 notes. So you want to define that first. So the amount of $5 notes. And of course, because the amount of $1 notes would be different, then now you could say and let Y, or you don't even have to say and let. You can just say and Y be the amount. We should have an off here. All right, so I'll put it on here. So you would have off, and the off should also be here. So, and Y be the amount of $1 notes. So once you have defined your unknown, meaning you're stating what you're using them for, then now you go ahead and form your equation. So you can say, therefore, one equation would be what? 5x plus $1 notes, it would be 1y, which is just y, would be equal to $74, but you're going to just write 74 without the dollar sign. And that you could call that now equation 1. All right, so what else can you say in terms of an equation? Which other equation you could come up with?
Sir, go again, which what?
You need another equation. So can you come up with another one? How many notes in total were being used?
50, sir.
So how would you get 50 notes in total? Suppose you have 10 $10 notes? How many notes you have?
10 $10 notes, sir.
10 $1 notes. How many notes you have?
10.
10. How much more you'd need to get to 50?
40.
That means if you have 10 $1 notes, then the rest would have to be what? In $5 notes, right?
Yes, sir.
So how many $1 notes? How do we define the amount of $5 notes and the amount of $1 notes?
In this, in the 50, sir.
And in terms of what we have used for our unknown, what did we say up here?
5x what? 5x plus y?
No, not the equation. What we wrote here in
Oh, let x be the amount. Yeah.
So what say if X is the amount of $5 notes and y is the amount of $5 notes we do in order to get 50?
Yes, sir. With add.
That was a question, you know. What you
Add, sir.
what you gonna add, Miss Wilson?
The $5 notes and the $1 notes, sir. To get the 50.
You're not going to add the $5 notes and the $1 notes. You're going to add the amount. What is the amount?
The amount of notes, 50.
That's a total, but we are saying, what is the amount of $5 notes?
Oh, but sir, we don't know yet.
How many $5 notes you have?
I'm not sure yet, sir.
You don't know. How many $1 notes you have?
Not sure.
You don't know, but you did say over here, let X be the amount of $5 notes and let Y be the amount of $1 notes. So what you're going to say now?
X plus y equals 50, sir.
Exactly. So you will have X plus Y is equal to 50. And from here now, you would have formulated two equations that you are now able to solve simultaneously. All right. Now, what is it that you're focusing on is how many $5 notes. So which of the variable you're going to solve for?
X, sir.
Right, so if you are solving for X, and that's what they're asking you for, it means that you really don't need to calculate what Y is. But I would say practice to calculate Y in terms of practice. But when you're asked a question in exam, just solve what they're asking you for. All right, Miss Green, are you following so far? Are you seeing how to formulate these equations?
Sir, could you go over it one more time, please?
So, Ms. Green, what we are saying is that when we get ready, when we are given a ready question where you can identify something that you don't know. So in this case, ignoring what was written down here for a moment. And then let's look at the question itself. It says a bill for $74 was paid with $5 notes and $1 notes. A total of 50 notes were used. Now, they said find how many $5 notes, how many $5 notes. But before you even go to finding how many $5 notes, you need to think about, do you know the number of $5 notes? And do you know the number of $1 notes? Or in other words, do you know the amount of $5 notes? And do you know the amount of $1 notes? So that's what you should ask yourself. Do you know, Ms. Green?
No, sir.
Right. Now, so you know that you must have some amount of $5 notes. You must have some amount of $1 notes. The thing is, you don't know how many $5 notes and you don't know how many $1 notes. But you're not going to assume that they have the same amount. So in this case, you can say, let X be the amount of $5 notes and let Y be the amount of $1 notes. Since the amount of $1 notes is different from the amount of $5 notes, you use a different letter to represent the amount of $1 notes. Is that clear, Ms. Green?
Yes, sir.
All right, so that's what we did here by saying to our reader or the examiner what we're using for the amount of X notes and for the amount of Y notes. In other words, what we are using in terms of $1 notes, how many, what variable we're using for $1, what variable we're using for $5. So we're using X for the amount of $5 notes, and we're using Y for the amount of $5 notes. Now, with that said, the next thing we want to do now is to see how we can formulate two equations with X and Y. Now, if you have a bill which is $74, you pay it with $5 notes and $1 notes. So what can you say in terms of the amount of $5 notes and the amount of $1 notes? How many $5 notes would you use? And how many $1 notes would you use? Now remember, those are what you did not know. And that's what you're saying X is. X is the amount of $5 notes. And you're saying Y is the amount of $1 notes. So what kind of equation could you write to equal to $74 with some amount of $5 notes and some amount of $1 notes? What comes to your mind, Ms. Green?
Sir, what came to my mind was X plus Y will give me the 70.
Well, X plus Y is just the amount. It is not in terms of dollars, you know. X and Y are not in terms of dollars. So if you say X plus Y equal to 74, that would not be correct. You follow? X is just how many $5 notes, and Y is just how many $1 notes. You follow what I'm saying? So in order to get a total of $74, you would have to use X times $5. So however many $5 you're going to use would be X amount. However many $1 you're going to be would be Y amount. So you would have 5X and 1Y, which is just Y. You follow?
Yes, sir.
Right. Now, when you're talking about now the total number of notes, this is not talking about any dollars. 50 is not a monetary value here. 50 is just how many notes you have in total. So if you have X amount of $5 and you have Y amount of $1, so in total, if you add these two, you should get the total amount of notes to be 50. You following?
Yes, sir.
Right. So the hardest thing to do with these questions is to form the equations. So once you have formed the equation, you just apply the same rule that you'd have learned when you're solving simultaneous equations. So all those rules would apply. So now you would decide to eliminate either X or Y. And in this case, because they're asking you for $5 notes, how many $5 notes, it means that you just want to solve for X. So if you're just solving for x, you just can eliminate y. Now, what is the criteria that you need to eliminate y? One second, guys. Yes, guys, sorry about that. So in order to eliminate y, because we want to solve for x, what must we ensure that is happening with the y's in order to eliminate that? This way, some.
They are the same, sir, equal.
It's green, is that the case?
I was going to say that there's a subtracting.
Oh, no, none of you give me the correct answer. What is it that you should ensure before you can subtract or add?
Something with the sign, sir.
Before we even get to the sign this way, so what's the first step? In order to eliminate, what you need to do? You have to ensure that the coefficient of the unknown that you choose to eliminate is the same in both equations. You don't remember that?
Yes. Yes, sir, but yes, sir.
Right, so you have to bear that in mind. Even though they are already the same,
Right, yes, sir.
make sure that you remember that that is one of the conditions that you have to satisfy first. All right. So that condition where the coefficient of y is satisfied, so we see that the coefficient of y would be 1 in both of the equations. And so from that point now, we can decide now whether or not we're going to add or subtract in order to eliminate. So what do we do here in terms of eliminating? Add or subtract?
Subtract, sir.
Okay. What is the condition for subtracting?
So it applies to everything. It applies to everything.
You know that thing that which is kind of bad for students is that you don't take the time out to go back over the notes to learn the rules. You need to do that, guys, and you cannot just wait until the class to do that. The moment you learn, you're taught these rules, you should try to commit them to memory. So you have to review them over and over again because they don't stick if you just see them one time only. You have to look at it over and over again a number of times before it sticks. So in order to add or subtract, you look at the signs of the unknown that you are eliminating. Now, in this case, the signs of y would be 2 pluses. So if the signs in the 2 equation for y, the signs are the same, you subtract. But if one is a plus and one is a minus, then you add. So it means that if you have 2 pluses in this case, you're going to subtract one equation from the other. In this case, we would take away equation 2 from equation 1. Now, if you had 2 negative signs for y, you would still subtract because the condition is that the signs must be the same